All right, good day, Tri-City Geometry. I'd like to start with prayer. Gracious God in heaven, continue to be with us as we face this challenging situation for our school year. Bless us with perseverance unto the end. Give us diligence and give us joy in accomplishing our work. Thank you for the end of the school year upcoming in less than a month, and pray that you would help us to finish strong, to take great delight in what we're doing and what we're learning, and to give a good account of ourselves to our teachers, but mostly to you. We ask in Jesus' name, amen. Okay, so last lesson we talked about the surface area of prisms, and now we're going to remove one of those bases at the top so that we can talk about pyramids and cones. So we start off with this lesson opener and what they want us to do. State the number of faces of each figure: a square pyramid, a pentagonal pyramid, an n-gonal pyramid, a dodecahedron, and an icosahedron. So stop and pause and work that out. Remember that a pyramid only has one base, and then based on the shape of the base is how many other faces it's going to have. All right, so our first one is 5, right? You've got the one base, and then the square creates 4 other faces. Pentagonal will be 6. So based on these two, how many would an n-gonal, in other words, any shape base, will be what? Well, it'll be the number of the sides of the base plus 1, because you've got to add the base. So it's going to be n plus 1. A dodecahedron, right? Deca is 10. Do is like dos in Spanish, right? It's 2. So that's 12. Icosahedron, this one you may not be familiar with the term, but it is 20. So if you think of those 20-sided dice that are used with, role-playing games and other kinds of games, icosahedron, okay? All right, so here is our pyramid. And so we've got this H marked out, and that is known as the pyramid height. That goes from, or its altitude, it's labeled here as a height, but it's an altitude going from the vertex at the top straight down perpendicular to the base. So this leads us to say that the lateral edges of a pyramid are the segments formed by the intersection of the lateral faces, and they intersect at the pyramid's vertex. So I want you to pause right here, and I want you to name some of these lateral edges. So anything starting with an A, right? AF, AE, AD, those are all lateral edges, as opposed to base edges, which would be like DE, FE, FB. The segment from the vertex that is perpendicular to the plane of the base is its altitude, and the altitude's length is the pyramid's height. And again, they're going to capitalize this because they're going to distinguish it from the height of each of these lateral faces. We'll talk about that in a minute. So again, surface area is going to be the surface area of the lateral faces. That's L, right? You remember that from the last section, plus the area of the base. So when we add all that up together, we get the total surface area, which is a capital S. And so again, they're using these capital letters because these symbols are often comprehending more than just the surface of one area, one face. L stands for, in this case, all 5 faces. And we're going to figure out how to calculate that more quickly than doing just each individual triangle. So here you can see a square pyramid, and they've put it out into a net so that you can see how we do this. So first of all, we've got the base edges, that's labeled S, right? Then we've got the height of the pyramid, that's labeled H. And then we have the height of each lateral face, and they're labeling that L, okay? So if you think of L, if you think of your triangle area, 1/2 base times height, in this case, it would be 1/2 L times S. And then notice the green line here on the left. We've got this apothem of the base. And I want you to notice also what shape, if we take capital H, L, and A, what shape do we have there? Well, we have a right triangle. So you may have certain questions where you're going to be given two of these, and you've got to find the third one. And what would that involve? Well, it would involve the Pythagorean theorem. Okay, it would involve the Pythagorean theorem, where maybe you're given the height and the length of the height of the lateral side. You've got to find the apothem because that'll be involved in the calculation. Anyway, so this is just to show you that the surface area of the entire thing is the area L of the 4 different lateral faces plus the area of the base, which in this case is side times side. Okay, find the surface area of the regular pyramid. So the area of each of the lateral faces, right, will be 1/2 base times height, okay? And you're given base edges are 7 inches. You're given that the lateral height is 16 inches. So that comes out to 56 inches for each one of these. Okay, so remember, capital L would be the total. Right here, the capital A is just the area for each of these lateral faces. So what is going to be the L, the total of the lateral faces? Well, it's going to be the total number of faces, okay, which again, we can calculate that by the base edges at the bottom times the area of each individual lateral face. So in this case, 5, right? So 5 times 56 gives us a surface area of the lateral surface area of 280 inches. So we've got that. Now we've got to find the area of the base, that pentagon. And if you go back to chapter 7, you'll remember that for a regular polygon, it's 1/2 the apothem times the perimeter, okay? 1/2 the apothem times the perimeter. And in this case, the perimeter is going to be 5 sides, 7 inches, right? 5 times 7, and then the apothem is 4.8. So again, we've got to know the apothem and the length of each side of the polygon. We come up with 84. So we're going to add that to the L, right? Total surface area is the lateral surface area, capital L, plus the base surface area, capital B. That gives us 364 inches, okay? So the lateral surface area of a regular pyramid. Now here you're going to want to look at the bottom of page 413, because what they're going to do is they're going to show you how you can transform this into a regular formula. So if the lateral surface area is the number of sides times the area of each of those sides, lateral sides, then we can see that 1/2 SL, and again, S here stands for the length of each base side, L stands for the height of each lateral side. So again, at the picture at the top, you can see the S and L. Now we can use the the associative property to move that around so that we can get the number of sides times the base side, and that becomes the perimeter. So NS is substituted here by this P. So it's 1/2 the perimeter times the height of the lateral surface side, which is L. So this is how we can, instead of doing each individual lateral side, as long as we know what the perimeter of the base is, the lateral, which is the lateral area, times this allows us to combine all the different sides. And so the total surface area of a regular pyramid, now we can combine this. So it's, remember the base is going to be 1/2 the perimeter times the apothem. So now we just combine these two terms, and this is at the top of page 414. We're taking total surface area S equals lateral surface area L plus base surface area. We're substituting the formulas, and then we're using the distributive property to distribute out the 1/2 perimeter. And so we've got the L, which is the height of the lateral face, and the A, which is the apothem. This leads us to our theorem. The lateral surface area of a regular pyramid is lateral surface area equals 1/2 perimeter times lateral surface height, L. Its surface area total surface area is 1/2 perimeter, parentheses, lateral height plus apothem, where P is the perimeter of the base, L is the slant height, right? So that those triangles are slanted, and so that's why it's called the slant height. And A is the apothem of the base. So again, sometimes you're not going to know what one of these is. They may give you a couple of them, and they'll give you the total surface area. And so you're going to have to divide out. You're going to have to use this formula to divide out. And for instance, solve for A or solve for L. Okay, so just be aware of that. Find the lateral surface area and surface area of a regular pyramid. So what do we have here? We have a hexagonal regular pyramid. So we know what S is, so we could calculate the perimeter rather quickly of that. We know what the slant height is. It's 23 inches. In other words, the height of each lateral face, the slant height. So if we apply our formula, right, go back and read that theorem a couple of times. So the perimeter equals the number of sides times the length of each side. So that's 6 times 12. That gives us 72 inches for the perimeter. So our lateral surface area is 1/2 the perimeter times the slant height. We know that that slant height is 23. So we do 1/2 of 72, which is 36 times 23, gives us 828 inches. So that's just our L. Now we've got to add that to the base height. Now the base height is, or the base area I should say, is going to be 1/2 perimeter times the apothem. So the apothem, they didn't tell us the apothem, right? So this apothem happens to be a hexagon is made up of what? It's made up of equilateral triangles. So we have to go back to our 60-60-60 triangle to find the apothem. So in this case, or again, we could use Pythagorean theorem and recognize that this is a 30-60-90 triangle, right? The bottom right angle is a 60, the 90 is the apothem, it's perpendicular, and then the 30 would be at the top. So that's how they automatically know that if the hypotenuse is 12, the one leg is 6, then it's got to be 6 times the square root of 3. So the perimeter is 72. The lateral surface is 828. And then the apothem is 6 times the square root of 3. So again, using our formula, 1/2 perimeter slant height plus apothem gives us this. We put all that together and we end up with 828, right? That's the 1/2 72 plus 23. Then we distribute this out again, 1/2 72 times 6 times the square root of 3. And our approximate is 1202.1 inches squared. So again, it's somewhat involved, but once you know how to just plug the numbers in, the question is do you know your slant height? Do you know your apothem? Do I have to do some kind of calculation to find my apothem or to find my slant height? So that's going to be one of the questions you're going to have to wrestle with here. Now, we're transitioning from pyramids to cones. As the number of sides of the base of a regular pyramid increases, the pyramid approaches the shape of a cone. The base's perimeter approaches the circumference of a circle. And the pyramid's apothem approaches the radius of a circle. So we're going to be using the same principles, but now we're going to be involving pi as we transition from perimeter to circumference, or as we transition from apothem to radius. They map this out here for us. So a regular pyramid, the lateral surface area is 1/2 the perimeter times the slant height. So we apply that to a cone. So look here at the right figure. The slant height here is still going to be L. And instead of dealing with a perimeter, we're going to be dealing with a circumference, right? So the lateral surface area, in other words, if you think of wearing a cone hat, it's going to be everything that consists of the cone hat, because there's going to be no base. Your head's going to be the base. And that's going to be lateral surface area equals 1/2 circumference times the slant height, not the height that's in the middle there from the vertex down to the center, going perpendicular, but that diagonal line on the right, the slant height. So the total surface area for the cone is going to be, again, lower right. Surface area is going to be lateral surface area plus base surface area. And so we've got two formula for that. And we can distribute it out, the 1/2 circumference. So just like with the regular pyramid, we get 1/2 the perimeter, parentheses, slant height plus apothem. For the surface area of a cone, we get 1/2 the circumference, parentheses, slant height plus the radius. So this leads us to our theorem. The lateral surface area of a circular cone is L equals 1/2 circumference slant height. And its surface area, the total, is S equals 1/2 the circumference, parentheses, slant height plus radius, close parentheses, where C is the circumference of the base, L is the slant height, and R is the radius of the base. So please pause here and read through this several times. Find the height of a circular cone if its surface area is 144 centimeters. So here they're giving us what? They're giving us capital S, and they're wanting us to derive from this, only knowing the total, and knowing what the radius is, how can we find the height? And that's the h, right? Not the slant height, but the height. So we put in our formula, and we're going to be given s. So we're going to be given the left side. So s is 144 pi, right? Pi d. And then we've got on the right side, we have the the radius, which is 6, right? And the circumference is 2 times the radius. So that's where we get 2 pi 6. And then the lateral surface area is 1/2 the radius or the circumference plus the lateral height. So when we do all of our combining here, we find that 100, and we divide pi out from both sides. We get 144 equals 6 times the lateral surface area plus 6. Now, what we're going to do here is we're going to use the Pythagorean theorem, right? Once we find the slant height and we know the radius, we're going to use the Pythagorean theorem to find the height. So we distribute the 6's, or we divide both sides by 6, excuse me. So 24 equals L plus 6. We subtract 6. So the slant height is 18. The radius is 6. So now we can calculate what the height is. So we use our Pythagorean theorem, 6 squared plus the height squared, right? That's the missing leg, equals 18 squared, the slant height, the hypotenuse. So therefore we get the square root of 288, which we can reduce down to, that's 2 times 144. So 144 is a square, so we can take the square root of that. So we get 12 times the square root of 2. So there is our height. Approximately 17 centimeters. So what is the lateral surface area of a cone? Now we're up to page 416. It is pi radius slant height, pi radius slant height. And again, this is like the apothem or the perimeter that we looked at earlier. Total surface area of a circular cone is going to be the base area, pi r squared, plus the lateral surface area, pi rl. And again, we can separate out, we can distribute out the pi r. The surface area of a cone is the sum of the lateral surface area and the area of the base. And so here you can see what we've done. We're summarizing here what we learned in the last section at the top, right? A cylinder that has 2 bases, whether it's a polygonal cylinder, which would be a prism, or a circular cylinder. And then in this section, we've covered the cone, and these are the different formula, or formulae would be the proper plural there, for how to calculate this. Okay. So here we have the 5 regular polyhedra, also known as the Platonic solids. These were introduced to us back in chapter 1, section 7, and we touched on them briefly at the beginning of this chapter. And what you need to realize here is that each of these polyhedra are regular because they all have each of the surfaces, each of the faces is also a regular polygon. So just take a quick look and see if you can, it's fairly easy to identify these shapes, right? So regular tetrahedron, they're all triangles, regular triangles, right? Regular hexahedron, a cube they're all squares. The dodecagon, they're all pentagons, okay? They're regular pentagons. So that allows us to use some of the things of how we figured out the areas of regular pentagons in order to be able to combine all those, basically multiply them by the number of faces in order to come up with the surface areas of these regular polyhedra. So that's what our final section here in this chapter is about. To find the surface area of a Platonic solid, multiply the area of one face, right? That would be capital A, by the number of faces, lowercase. Blake sells calendars in the shape of a regular dodecahedron. So first of all, how many sides does that have? It has 12. Find the total surface area of a calendar if each face has an edge of 1.8 inches and an apothem of 1.1 inch. So our total surface area is the number of sides, n, times the area of each side. So we know that a dodecahedron has 12 sides, and the way that and you can see that they're in the shape of a pentagon. And so we find the area of the pentagon by 1/2 the apothem times the perimeter. Now, what we can do here is, so we're going to distribute the 1/2 to the 12, and then the perimeter is the 5 edges, right? The edge of each perimeter is 5, so that's how we end up with 30 apothem edge. So this is the total, right? We're able to quickly calculate what the total surface area is for this dodecahedron by knowing that each face is a pentagon. So there's 5 edges to a pentagon. So we put in the edge is 1.8, the apothem is 1.1. We multiply that by 30, and we end up with a figure of 59.4. So that's the total surface area. That's the capital S for a dodecahedron, simply by knowing what the length of each edge was and what the apothem for each face was. All right, so I'd like you to do these first 10 problems and then a couple of problems in B and then some review at the end. Now the ones in B, there's some large figures here, but also you need to realize that they may be asking you just for the surface area of what you can see, right? So that means you're not going to have to worry about the base. You're only going to have to worry about the capital L, the lateral surface area. And then you've got another one with an ice cream cone. And so the next time you go and buy an ice cream cone at Cumbies, you're going to know how to figure out the surface area of that wrapping that covers it. All right. So just to let you know, next week I'm going to be out of pocket for about half the week. So I'm probably only going to give you one other assignment next week, meaning 9.4.